CBSE Class 10 Math, chapter-wise revision. We are in chapter number 7, Coordinate Geometry. This entire chapter has got only 4 concepts. The first one is distance formula. The second one is section formula. The third one, midpoint formula, is actually a variant. It's a special case of the section formula. And lastly, area of triangles. We have run through all of these 4 concepts as a quick recap. We also solved 10 questions which are lookalikes of questions which have tested similar concepts in the past 4-5 years board papers and sample question papers. We looked at question papers from 2016 all the way to the sample question paper given by CBSE for 2020. Right? Let's get started. We'll start with the first of the concepts, distance between 2 points whose coordinates are x1, y1 and x2, y2. The distance between those 2 points would be square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Let's consolidate this with a few examples. Start with the first one. Prove that the points 4, 0, 7, 4 and 11, 1 are the vertices of a right-angled isosceles triangle. We'll have to prove that by joining these 3 points, we're going to get a triangle which is a right isosceles triangle. Let's start with the isosceles. What's an isosceles triangle? An isosceles triangle is one in which 2 sides are equal. So what we are going to do is, we're going to be finding out, let's say the vertices are A, B and C. We'll find out the lengths of the 3 sides of the triangle, AB, BC, CA, using the distance formula. And if we find that 2 of those sides are equal, we know we are talking about an isosceles triangle. How do we prove that this is a right triangle? Known the 3 sides of the triangle, known the measure of the 3 sides of the triangle. If it's a right triangle, then it's going to basically satisfy the Pythagoras theorem. So let's set about doing that. So the first point for us is to basically find out the lengths of the 3 sides of the triangle joining points AB, BC and CA. Let's quickly run through it. Length of line segment joining 2 points x1, y1, x2, y2 is square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So let's run it through this. Let's start with, let's say this is coordinates of point A are 4, 0, coordinates of point B are 7, 4 and that of point C are 11, 1. Let's find out the length of AB. AB is equal to square root of x2 minus x1 the whole square, which in our case is going to be 7 minus 4 the whole square plus y2 minus y1 the whole square, which is 4 minus 0 the whole square. So this is equal to square root of 7 minus 4 is a 3, 3 square is equal to 9, 4 minus 0 is a 4, 4 square is equal to 16. 9 plus 16 is a 25, square root of 25 is equal to 5. So found out the measure of AB. Let's find out the length of BC. BC is equal to square root of, we'll take x1, y1, x2, y2 in that order. So it's going to be x2 minus x1 in this case is 11 minus 7 the whole square plus y2 minus y1 is 1 minus 4 the whole square. So this is equal to 11 minus 7 is a 4, 4 square is equal to 16, 1 minus 4 is a minus 3 square is a 9, 16 plus 9, 25 square root is equal to 5. In the face of it, we got AB equals BC. So we actually established that this is an isosceles triangle. Let's quickly find out the measure of CA. CA is equal to, again the length is x2 minus x1 the whole square, which is 4 minus 11 the whole square plus y2 minus y1 the whole square, which is 0 minus 1 the whole square. So this is equal to square root of 4 minus 11 is a minus 7. Minus 7 square is equal to 49. 0 minus 1 is a minus 1. Square of that is a plus 1. 49 plus 1 is 50. So this is equal to root 50. So 2 sides equal, 1 not equal. It's an isosceles triangle. So that part is done. That's what we'll do is we'll have to prove the Pythagoras theorem. So step 1, let's find out the square of all these 3 sides. AB square will be equal to 25 because AB is equal to 5. BC square is again equal to 25. CA square is equal to square of root 50, which is equal to 50. Notice this CA square is a 50, which is sum of the squares of the other 2 sides because AC square or CA square is equal to AB square plus BC square. We know that this given triangle is a right triangle. We know it's a right triangle. We know it's an isosceles triangle. So this has been proved that it's a right isosceles triangle. 2 sides are equal and the 3 sides satisfy the Pythagoras theorem. Quickly summarize it in a printed form. Finding out the length of AB, which is equal to 5. BC is also equal to 5. We computed CA in the last slide to be equal to root 50. So these are the 3 sides of a triangle. 2 sides are equal. So it's an isosceles triangle. It's checking out whether Pythagoras theorem will be satisfied. Root 50 square is a 50. This is sum of the squares of the other 2 sides. Which means Pythagoras theorem is satisfied. This is a right triangle. It's a right triangle. It's an isosceles triangle. It's a right isosceles triangle. There's one more example. The distances of point P whose coordinates are x, y. From these 2 points A 4, 2 and B minus 2, 4 right? So essentially are equal, which essentially they're saying that PA is equal to PB. Then prove that 3x is equal to y. Approach, we're going to find out the length of PA in terms of x and y, because the coordinates of PA are given in terms of x and y. We're going to find out the length of PB. We'll equate those two, solve for x and y, and see if we can get to this relation. Let's get started. Let's start with this. We know the distance formula. We'll find out the length of PA. PA is equal to x2 minus x1, which is x minus 4 the whole square, plus y minus 2 the whole square. PB will be equal to x minus of minus 2, which is x plus 2 the whole square, plus y minus 4 the whole square under root. So that's the value of PB. The question says PA equals PB, which means the square of PA should be equal to the square of PB. So let's square this. PA square, the square root will go of PA square is going to be x minus 4 the whole square plus y minus 2 the whole square. This is PA square. PB square, the square root goes off, will leave us with x plus 2 the whole square plus y minus 4 the whole square. So expand and solve and see whether you are able to get to this relation. X minus 4 the whole square will translate to x square minus 8x plus 16. Y minus 2 the whole square is y square minus 4y plus 4. This is equal to, on the right hand side, x plus 2 the whole square is x square plus 4x plus 4. And y minus 4 the whole square is y square minus 8y plus a 16. X square gets cancelled with x square on both sides. Y square gets cancelled with y square on both sides. 4 gets cancelled with 4 on both sides. 16 on both sides get cancelled with each other. Let me take this minus 8y to the left hand side. 8y minus 4y will leave us with 4y. Take the minus 8x to the right hand side. Will leave us with 4x plus 8x, which is equal to 12x. Both sides are divisible by 4. Let's divide it. So we get y is equal to 3x, which is what we needed to prove. Quickly summarize it in a printed form. PA is equal to PB. So PA square should be equal to PB square. Squaring both sides, expanding it. X square with x square, y square with y square, 16 with 16, 4 with 4. Taking the 8y to the left hand side will give you a 4y. Taking the 8x to the right hand side will give us a 12x. 12x equals 4y or 3x equals y. Whatever we needed to prove, we have proved it. Right. Let's move on. When all was this question, this distance formula tested? Quite a few questions since 2016. Look at it. 16, 17, 18, 19 board papers, 20 sample paper. Every single year this concept has been tested. So get conversant with it. Let's move to the second concept, which is a section formula. Coordinates of a point dividing line segment joining points x1, y1, x2, y2 in the ratio m is to n internally is given by mx2 plus nx1 divided by m plus n. This is the x coordinate of that point. My2 plus ny1 divided by m plus n. This is a y coordinate of this point. Let's get a few questions to understand and solve this and check out how this was tested. All the questions that we are doing right now are basically questions as lookalikes that have been tested in the past years. Right? It says that what ratio does 7, y divide this line segment joining point P9, 6 and Q4, minus 4. Also find out the value of y. We need to find out, let's say it divides it in the ratio of m is to n. 7, y divides this line segment in the ratio m is to n. So we're going to be applying the section formula, equating the x coordinate first, finding out m is to n. Step 2, using that m is to n, we'll find out the value of y, right? These are two steps that we're going to be following. It divides it in the ratio of m is to n. So let's find out what are the coordinates of point P. Coordinates of point P will be equal to mx2. So mx2, this is m is to n. mx2 is equal to 4m plus 9n, I'm sorry. mx2 plus nx1 divided by m plus n, my2 is equal to minus 4m plus ny1, which is equal to 6n divided by m plus n. This is what we have. We know the coordinates of this point P is equal to 7, y. Let's equate the x coordinates on both sides. So which essentially is 4m plus 9n is divided by m plus n is equal to a 7. Cross multiply and expand it on the right hand side. 4m plus 9n is equal to 7 times n plus 7 times n. m plus n. 7m plus 7n. Take the n terms to one side, we get 2n. m terms to one side, we get is 3m. So m by n is equal to 2 by 3, or the ratio m is to n is equal to 2 is to 3. What ratio does this point divide this line segment? It divides it in the ratio of 2 is to 3. Let's quickly consolidate it in a printed form. The ratio in which it divides, let it be m is to n. So therefore, equating the x coordinate, 7 is equal to mx2, m is to n, 4m plus 9n divided by m plus n. Solving for m and n, getting the ratio as 2 is to 3. Now that we have the ratio as 2 is to 3, we know that it divides it in the ratio of 2 is to 3. Let's find out the y coordinate, which is equal to my2, 2 times minus 4 plus ny1, which is 3 times 6 divided by m plus n, which is 2 plus 3. That's a y coordinate, which is the value of y. This is equal to minus 8 plus 18 divided by 5 is the answer. Minus 8 plus 18 is a plus 10. Plus 10 by 5 is equal to 2. So y is equal to 2. In consolidated in a printed form, my2 plus ny1 divided by m plus n is a y coordinate. M is to n is a 2 is to 3. y1 and y2 are 6 and minus 4. Plugging it in, we get the value of y to be equal to 2. To one more question, again consolidating the section formula idea. The point which divides this line segment 5, minus 6 and 2, 6 in the ratio 1 is to 2 internally lies in which quadrant? It's a objective type question. Approach, let's find out the coordinates of the point and then identify which quadrant it falls under. Right? Let's get started. We know the ratio in which it divides. Let's find the coordinates of this point first and then identify which quadrant it falls under. It's dividing it in the ratio of 1 is to 2. These are the points that we have. We know the section formula is mx2 plus nx1 divided by m plus n and my2 plus ny1 divided by m plus n. Quickly marking what are x1, y1, x1, y1, x2, y2. So absolutely no confusion. mx2, which is 1 into 2 plus nx1, which is 2 into 5 divided by m plus n, which is equal to 1 plus 2, comma, my2, which is 1 into 6 plus ny1, which is 2 into minus 6 divided by 1 plus 2. So this will be the coordinates of this point, right? Let's quickly find out what this is. This is a 2 plus 10, which is equal to 12 by 3, which is a 4, comma, this is a 6 minus 12, which is equal to minus 6 divided by 3, which is equal to minus 2. So the coordinates of this point are 4, minus 2. Let's quickly draw the rectangular coordinate system and check out what are the quadrants. Quadrant 1, 2, 3 and 4. Which quadrant has x as positive and y as negative? That's a fourth quadrant. So this point lies in the fourth quadrant. Summarize it in a printed form. Found out the coordinates of that point using the section formula, which works out to 4, minus 2. 4, minus 2 is the fourth quadrant point. So this point lies in the fourth quadrant. Choice D is the answer. When was the section formula idea tested? Quite a few years. 2016 is probably a paper where it was not tested. 17, 18, 19 sample paper, 19 board paper, and both the basic and the standard versions of 2020 paper. So again, this is a concept that you definitely need to know. Move on to the next concept. This is a midpoint formula. Midpoint formula, as I mentioned, is a special case of the section formula. It's a midpoint. So let's say point P and Q. Then we have a point, let's say A, which is dividing it in the ratio of m is to n. If it is a midpoint, it is going to divide it in the ratio of 1 is to 1. The coordinates of the midpoint are x1 plus x2 by 2, y1 plus y2 by 2. Essentially substitute m as 1, n as 1 in the section formula. You will get this answer. Quickly run through a couple of questions to consolidate this idea. Points P and Q trisect the line segment joining points this, right? It's trisecting. What do we mean by trisect? It's going to divide it into 3 equal parts. P is near to A. That's what they've said. Find the coordinates of points P and Q. See, this is point A. This is point B. The line segment, the black line segment joins these 2 points. We know the coordinates of A are 4, 2. And the coordinates of B are 7, 5. P and Q trisected. P is closer to A. So this is point P. This is point Q. They trisected. They're going to divide this entire line segment into equal parts. So AP is equal to PQ is equal to QB. Just for a moment say that measures X units each. So this is what we have. Now look at it. AP is equal to X. PB is equal to 2x. So P divides AB in the ratio of 1 is to 2. Right? Now that we know in what ratio P divides it, and we know the coordinates of points A and B, using the section formula, we can find out the coordinates of point P. mx2 plus nx1 divided by m plus n, my2 plus ny1 divided by m plus n. What's the ratio in which it's dividing? It's dividing it in the ratio of 1 is to 2. So mx2 is 1 into 7. Plus nx1, which is equal to 2 into 4 divided by m plus n, which is 1 plus 2, which is the x coordinate of this point. my2, which is 1 into 5, plus ny2, which is 2 into 2, this divided by 1 plus 2. This will give us the coordinates of point P. Quickly verified. 1 into 7 plus 2 into 4, 1 into 5, 2 into 2. Perfect. So all of them are divided by 3 because it's a ratio of 1:2. So the coordinates of point P will be equal to 7 plus 8, which is 15 by 3, which is equal to 5, comma. This is a 5 plus 4, 9, 9 by 3, which is equal to 3. Found out the coordinates of point P, which is equal to 5, 3. Quickly summarize it in a printed form. Applying the section formula, this is point A, point P, point P. Divides this in the ratio of 1:2. So coordinates of point P are 5, 3. Now that you have found out the coordinates of point P, just hold on for a minute. This is A, this is B, this is P, this is Q. We said AP is an X, PQ is an X, QB is an X. Forget this part right now. Let's just focus on PB. PB has PQ as X and QB as X, which means that Q is the midpoint of PB. Q is the midpoint of PB. And the coordinates of Q are going to be x1 plus x2 by 2, y1 plus y2 by 2. What are the coordinates? This P is a 5, 3. So that is x1 by 1. B is already given to us in the question, which is a 7, 5. So the midpoint of PB is equal to x1 plus x2 by 2, which is 5 plus 7 by 2, y1 plus y2 by 2, which is 3 plus 5 by 2. So this is going to be equal to 12 by 2, which is 6, and 8 by 2, which is equal to 4. Coordinates of point Q are 6, 4. Let us run through this once more. We could have found this also as dividing it in section formula. But a better way to go about it is, once we have found out the coordinates of point P, we know that PQ is the same as QB, which means that Q is the midpoint of PB. Do we know the coordinates of P? Yes, we've computed it in the last slide. Do we know the coordinates of B? Already given in the question. Midpoint formula is a very simple formula to apply. x1 plus x2 by 2, y1 plus y2 by 2. Pick the points x1, y1 as 5, 3, x2, y2 as 7, 5. Plugged it in, got the answer as 6, 4. So coordinates of point P are 5, 3 and coordinates of point Q are 6, 4. 5, 3 and 6, 4. It's a lovely question to consolidate the idea of midpoint and also understand a key property about parallelogram, right? Coordinates of the 4 vertices of parallelogram are given. Find the values of A and B. Hence, find the length of its side. So we need to do two things. We need to find out A, we need to find out B. These two are things that we need to find out. And in the process, we also need to, at the end of finding out A and B, find the measures of the lengths of its sides. Key property of parallelogram that we are going to be using, let's say these are the vertices A, B, C, D. In a parallelogram, the diagonals bisect each other. So AC will bisect BD, BD will bisect AC. They'll meet at a point O, which is a midpoint of both AC and BD. So midpoints of AC and BD are same. So all we need to do to find the values of A and B is basically compute the midpoint of AC, which is going to be the coordinates of point O. Compute the coordinates midpoint of BD, which is again going to be the coordinates of point O, and equate both. So the coordinates of point O computed as midpoint of AC. We're going to pick these two as the coordinates x1 plus x2 by 2, which is 1 plus 8 by 2, comma. Use the variable here because we have the variable as part of the y coordinate of point A. So that's A plus 3 divided by 2. Simplify it as 9 by 2, comma, A plus 3 by 2. Coordinates of point O as computed as a midpoint of AC. Let's find out the coordinates of point O computed as a midpoint of BD. So these are the coordinates of interest to us. x1 plus x2 by 2 is a 3 plus b by 2. y1 plus y2 by 2 is a 3 plus 5 by 2. So x coordinate carries a variable which is 3 plus b by 2. Y coordinate is 3 plus 5, 8 by 2, which is equal to 4. O is going to be the same whether it's measured as the midpoint of AC or the midpoint of BD. So we can equate the x and y coordinates. Let's start by equating the x coordinate. 9 by 2 is equal to 3 plus b by 2. Cancel the 2 on the both sides of the denominator. So you have 9 is equal to 3 plus b. Take the 3 to the left hand side. Get the value of b to be equal to 6. Let's find out the y coordinate. Equate the y coordinates, which is a plus 3 by 2 is equal to 4. Cross multiply. We get a plus 3 is equal to 8. Take this 3 to the right hand side. We'll get a is equal to 5. So you found out the values of a and b. A is equal to 5. B is equal to 6. Consolidate it in a printed form. Found out the midpoint of AC. This is the coordinates of O. Found out the midpoint of BD. Again coordinates of O. So we can equate the x coordinates and we can equate the y coordinates to find the value of A as 5 and B as 6. Now, these are the 4 coordinates. We have plugged in the value of A. We have plugged in the value of B. Both of those have been done. Let's say these are the 4 coordinates. A, B, vertices A, B, C, D. In a parallelogram, opposite sides are equal, opposite sides are parallel. So AB, whatever it measures, is going to be the same measure. It's going to be parallel, and whatever AB measures is going to be the measure of CD. Similarly, whatever is the measurement of BC is going to be the measurement of AD. Let's find out the value of AB using the distance formula. That will give us the value of CD as well. So measure of AB is equal to square root of, let's pick these two values, x2 minus x1 the whole square, which is 3 minus 1 the whole square, plus y2 minus y1 the whole square, which is 3 minus 5 the whole square. x2 minus x1 is a 3 minus 1, which is a 2. 2 square is equal to 4. 3 minus 5 is a minus 2. Minus 2 square is again a 4. 4 plus 4 is an 8. So the measure of AB is equal to root 8. Let's find out the length of BC. We're going to pick these 2 points to do that. Square root of x2 minus x1 the whole square, which is 8 minus 3 square, plus y2 minus y1, which is a 3 minus 3 the whole square. So this is equal to 5 square, which is equal to 25 plus 0. Root 25 is equal to 5. So measures of the sides are basically root 8 and root 8 and 5 and 5. Summarize it in a printed form. Found out the measures of AB and BC, and the lengths of the 4 sides have been arrived at. Right. Let's move on from here. When all was this idea of midpoint tested? Been tested in 17, 18, 19 sample paper, 19 board paper. So quite a few years other than 2016 from which I've combed the papers. It's been tested quite often. So again, this is an area where you need to have good idea about it and also need to know how to solve it when it's not directly asked. The parallelogram basically applied this midpoint formula, but you needed to know the concept, the property that the diagonals of a parallelogram bisect each other to be able to solve it. Let's move on to the last concept, finding out the area of the triangle. The vertices of the triangle, the coordinates of the vertices are x1 by 1, x2 by 2, x3 by 3. The area is given as half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Right? Keep this order 1, 2, 3, 2, 3, 1, 3, 1, 2. If this number ended up being a negative one, the numerical value is basically the area. Right? Areas cannot be negative. Alternatively, you could have drawn a modulus symbol here and found out the answer. Let's get solving few questions, understanding how this goes about it. The points A, B and C are collinear. Then find the value of k. The coordinates of A, B, C, all of them have k in it. And they said that these 3 points are collinear. What do we mean by collinear points? Collinear points are points that lie on a straight line. So A, B and C, according to this question, lie on a straight line. If 3 points lie on a straight line, you cannot form a triangle with them, which essentially means that the area of the triangle thus formed is equal to 0. So area of triangle ABC is equal to 0 if these 3 points are collinear. That's exactly what we are going to do to find out the value of k. Quickly run through this process. So area of a triangle whose vertices are this is given by this. So let's take this point to be x1, y1, x2, y2. Note it down because I don't want us to make any mistake whatsoever. This is equal to 0 is what we have because these 3 points are collinear. Let's set about equating this to 0. So half into, you don't even have to bother about the half because half is nowhere a 0. If something has to be 0, whatever is there in the square parenthesis is what should be 0. Let's keep the half. Let's move on with this. So x1, which is equal to a k into y2 minus y3, which is 2k minus of 2k minus 3. That's what we have. y2 is a 2k, y3 is a 2k minus 3 plus, close this parenthesis, x2, which is again a k into, we have y3 minus y1, which is 2k minus 3 minus of 4k minus 3. Write this carefully so we shouldn't make any mistake whatsoever. Plus x3, which is equal to a k plus 2, I'll close parenthesis for this, into y1 minus y2, which is 4k minus 3 minus y2, which is equal to 2k. Check it once, does not harm, right? x1 is a k, y2 minus y3 is a 2k minus of 2k minus 3. x2 is again a k, y3 minus y1 is a 2k minus 3 minus 4k minus 3. x3 is a k plus 2, y1 minus y2 is a 4k minus 3 minus 2k. So this is equal to half into 2k and 2k will get cancelled. Minus of minus 3 will leave us with a plus 3. So this part, entire thing is the 3k. 2k minus 4k, let's write this k, will leave us with a minus 2k. 3 minus of minus 3, these two will get cancelled. So we don't need to bother. Plus k plus 2 into, what do we have here? 4k minus 2k will leave us with a 2k minus 3. Let's expand this. This entire thing is equal to 0. We'll equate it to 0 in the next step. Half into 3k minus 2k square. Let's expand this term. plus 2k square minus 3k plus 4k minus 6. This entire thing is equal to 0. Minus 2k square gets cancelled with plus 2k square. 3k and minus 3k get cancelled. So we have half into 4k minus 6 is equal to 0. Divide this entire thing. So we're going to get 2k minus 3 is equal to 0. Or we get 2k is equal to 3. Or the value of k is equal to a 3 by 2. Quickly run through this entire thing. If k is equal to 3 by 2, then these 3 points are collinear points. Plugging it into the area formula, x1, y1, this is x1, y1, x2, y2, x3, y3, right. We run through it carefully. The 2k gets cancelled with 2k and we'll be left with the plus 3. The minus 3 and minus of minus 3 will get cancelled. We'll be having a net term of minus 2k here. The 2k and 4k will get cancelled to leave us with a 2k minus 3. That's what the next step is. Expanding it, we get this 2k square and 2k square getting cancelled. Half into 4k minus 6, which is 2k minus 3 equals 0. K is equal to 3 by 2. Run through these parts very slowly. You don't want to be making a mistake in this. Let's move to the next question. ABCD are the vertices of a quadrilateral. We need to find the area of the quadrilateral. We know the formula only for area of a triangle. Area of a quadrilateral is found out by basically dividing this quadrilateral into two triangles. So we'll find out the area of triangle ABC. We'll find out the area of triangle ADC, and then we'll add both those things to find out the area of this quadrilateral. ABC, x1, y1, x2, y2, x3, y3. For sake of convenience, write the formula once more. Half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. We're going to be taking the numerical value of it. If it's negative, we'll go with a positive value. So just plug in the values. Half into, what is x1? x1 in this case is 1. y2 minus y3 is 5 minus of minus 2. So I'll write it as a 5 plus 2. Plus x2 is a minus 4. Use a parenthesis, so no doubts. y3 minus y1 is minus 2 minus of minus 1. So minus 2 plus 1 is what we have. x3 is a minus 3. Again use parenthesis, so no confusion. y1 minus y2, which is minus 1 minus 5. So this is the area of triangle ABC. So this is equal to half into 5 plus 2 is a 7. We have a minus 1 left here. Minus 1 into minus 4 is a plus 4. Minus 6 left here. Minus 6 into minus 3 is a plus 18. So the entire number is a positive number. No sweat. Half into 7 plus 4 is 11. 11 plus 18 is a 29. 29 by 2. 14.5 square units is the area of triangle ABC. So found out the area of this triangle, which is 14.5. Let's find out the area of triangle ACD. To avoid any confusion of making any mistake, I'm going to write down the coordinates here. 1, minus 1. C is minus 3, minus 2. And D is 1, minus 5. Just write it once more, even in the exam. You don't want to be making mistakes here. Area is equal to, the formula is already there. So it's half into x1, which is 1, into y2 minus y3, which is minus 2, minus of minus 5, which is a plus 5. Plus x2, which is a minus 3, use parenthesis. y3 minus y1, which is minus 5, minus of minus 1, which is equal to plus 1. Plus x3, which is 1, y1 minus y2, minus 1, minus of minus 2, which is equal to a plus 2. Close parenthesis, this is equal to half into 5 minus 2 is a 3 into 1, which is 3. Minus 5 plus 1, which is a minus 4 into minus 3, which is equal to plus 12. Minus 1 plus 2 is a plus 1. So this is plus 1. So we have 12 plus 1, 13 plus 3, 16 by 2, which is equal to 8 square units. The area of this triangle is 8 square units. The area of ABC is 14.5 square units. So area of ABCD is equal to 14.5 plus 8, which is equal to 22.5 square units. Let's quickly summarize it in a printed form. Area formula. Substituting the values of A, B and C as x1, x2, y, x3, got the area to be equal to 14.5. If this is A, B, C, D, found out this area to be equal to 14.5. Running through the same exercise for ACD, A, B, C, D. Trying to find out the area for this triangle, which works out to 8 square units. This was 14.5. The lower one, ADC, is equal to 8. So area of the quadrilateral is 22.5 square units. Look at one more. It's a lovely question again. It's tested in one of the papers. It's a lookalike that we got here. The figure given below, vertices of triangle ABC are mentioned. These are the vertices. A line segment DE is drawn to intersect AB at D and AC at E. Very clear. Such that AD by AB is equal to AE by EC is equal to 1 by 4. Just make sense of it. AD, if it is an X, then they are saying the entire AB is going to be equal to 4X. Which means what will DB be? That's going to be equal to the balance, which is 3X. AE by AC, let's say AE is equal to Y. Then AC, according to this particular part, is equal to 4Y. Which means what's going to be EC? EC is going to be equal to 3Y. So what does this entire information mean? This entire information says that AD is to DB is 1 is to 3. Similarly, AE is to EC is also 1 is to 3. So it's essentially saying D divides AB in the ratio 1 is to 3 and E divides AC in the ratio 1 is to 3. This is what I'm going to consolidate it in a printed form. AD by AB is equal to 1 by 4. This is X. This entire thing is equal to 4X, let us say. So we said 4AD is equal to AB. And then we know that AB can be written as AD plus DB. Take this to the other side. 3AD equals DB or AD by DB is equal to 1 is to 3. So this D divides AB in the ratio 1 is to 3. Running through the same exercise, we get E dividing AC in the ratio 1 is to 3. Now that we know the ratio in which D and D divide AB and AC, we can find out the coordinates of D and E. Let's do that as a next step. Once you have found that, next step we're going to be finding out the area that we have been asked to find out. Compare the areas of ADE. We know D, we know E coordinates at the end of next step. So you can find out the area of ADE. We already know the coordinates of ABC. You can find out the area of ABC. Let's find out the ratio of those two areas. That's what comparing the areas of these two triangles mean. So about doing that, let's use the section formula mx2 plus nx1 by m plus n, my2 plus ny1 divided by m plus n. Going to find out using it as a ratio of 1 is to 3 between AB. So coordinates of point D, which divides AB in the ratio 1 is to 3, mx2, m is 1 and x2 is 1, 1 into 1 plus nx1, which is 3 into 4 divided by 1 plus 3. This is the x coordinate of this point. My2, which is 1 into 5 plus ny2, which is 3 into 6 divided by 1 plus 3. So what does this translate to? This is a 12 plus 1, 13 by 4, right? Not an integer. Don't worry about it. Many times it need not be an integer. 18 plus 5, 23, 23 by 4. These are the coordinates of point D. Let's find out the coordinates of point D, which again is going to divide this line segment. Which line segment? AC in the ratio 1 is to 3. So we're going to use mx2, which is 1 into 7 plus nx1, which is 3 into 4 divided by 1 plus 3. Ratio remains the same. So denominator is going to be the same. my2 plus ny1 divided by m plus n. 1 into 2 plus 3 into 6 divided by 1 plus 3. So this is equal to 7 plus 8, 15 by 4, comma, this is a 2 plus 18, 20 by 4, which is equal to 5. So we found out the coordinates of point D, we found out the coordinates of point D. Quickly summarize it in a printed form. Coordinates of point D, coordinates of point E, applying the section formula. All that is left is find out the area of triangle ADE. You know the coordinates of those 3 points. The coordinates of the 3 points are 4, 6, coordinates of point D, and this coordinates of point E. x1, y1, x2, y2, and x3, y3. Not very friendly calculation, but nevertheless, let's run through it. So this is equal to half into x1, which is 4, into y2 minus y3, 23 by 4 minus 5, plus x2, which is equal to 13 by 4, into y3 minus y1, this part at least is reasonable, 5 minus 6, plus x3, which is 19 by 4, into y1 minus y2, which is 6 minus 23 by 4. This is the area of this triangle. This is equal to half into, let's take 4 as a common denominator, 4 into 23 minus 20 divided by 4, plus 5 minus 6 is a minus 1. So let's write it as a minus of 13 by 4, plus 19 by 4, and let's take 4 as a common denominator, which will keep the left hand side as a 24. 24 minus 23. This is the area of this triangle. This is equal to half into 4 and 4 gets cancelled to leave us with a 3 minus 13 by 4 plus we have 1 by 4 here. 19 by 4 into 1 by 4 will leave us with 19 by 16 on this part. So this is equal to half into, let's take 16 as a common denominator. So 16 times 3, 48 minus 13 times 4, which is 52 plus 19. This is the area. So this is half into minus 4 plus 19, 15 by 16. So 15 by 16 into half is equal to 15 by 32. Found out the area of the smaller triangle ADE. Let's run through the same process, however meticulous it is, to find out the area of triangle ABC. ABC, so x1, y1, x2, y2, x3, y3. Certainly going to be a lot easier than what we found out the last time. x1, which is 4, into y2 minus y3, which is a 5 minus 2, plus x2, which is 1, into y3 minus y2, which is 2 minus 6, plus x3, which is a 7, into y1 minus y2, which is 6 minus 5. So this is equal to half into 4 into 3, which is equal to 12, minus 4, which we'll keep it this way, plus 6 minus 5 is a 1, plus 7 is what we have. So this is 12 minus 4, 8, 8 plus 7, 15. 15 by 2 is the area of triangle ABC. Quickly summarize both these things in a printed form. Area of triangle ADE, 15 by 32 square units. Area of triangle ABC is 15 by 2 square units. Basically, compare these two. Area of triangle ADE, what is it as a ratio of area of triangle ABC, which is 15 by 32 upon 15 by 2. So, which is 15 by 32 into 2 by 15. 15 gets cancelled with 15. 2 by 32 is a 1 by 16. So, the ratio of these two areas in terms of a fraction is 1 by 16. In terms of a ratio is 1:16. Summarize it in a printed form. Got the areas of ADE and ABC. Ratio is 1:16. Comparing the areas, this is what is the answer. Right. A time consuming question, definitely worth 4 marks. If you had an alternative in this question in the real examination, probably I'll suggest go with that because quite a lot to be done. We have to use the section formula, find out DE, then use the area formula to find out ADE and then ABC and then compare it. You could go wrong in quite a few steps in terms of calculation. So, avoidable question. These kinds of questions, they've appeared both in the NCERT book and has also been appeared as part of the sample question papers. Right? Essentially, some information is given in a coordinate geometry fashion and we'll have to find out the answer. In a playground, 4 friends Ram, Sam, Geeta and Kiran are at these 4 points A, B, C, D. Then a 5th friend Prem joins the group. We need to find out 3 things. Prem stands in the middle of the other 4 friends. Find out the coordinates of Prem. Let's come to the 2nd and 3rd when we reach there. So these are the coordinates that we have. Now Prem is in the middle. This is the point that we are talking about. So what does that mean? In terms of the x coordinate of Prem, it is going to be the midpoint of AC. So let's find out the midpoint of AC to compute the x coordinate of Prem, which is 2 plus 8 divided by 2, which is equal to 5. 10 by 2 is a 5. In terms of the y coordinate, it is in the middle of B and D. So let's compute the midpoint of BD to compute the y in the y direction, where is he standing. So we're going to pick up the midpoint of y1 and y2 in this case, which is 6 plus 2 divided by 2, which is 8 by 2, which is equal to 4. So coordinates of Prem are 5, 4. So this point is equal to 5, 4. Summarize it in a printed form. Along the x direction, so going with AC, so this x coordinate alone we are taking. In the y direction, it's a midpoint of BD, therefore we are taking those 2 points. 5, 4 are the coordinates of Prem. Let's move on to point 2. Point 2 is asking us to use the distance formula. What's the distance between Ram and Sam? A is where Ram is and Sam is in basically B. So we'll have to find out the distance between these two. Use the distance formula. So this is equal to square root of x2 minus x1 the whole square, which is 5 minus 2 the whole square, plus y2 minus y1 the whole square, which is 6 minus 4 the whole square. 5 minus 2 is a 3. So 3 square is equal to 9. 6 minus 4 is a 2. 2 square is equal to 4. So distance between Ram and Sam is equal to 13 units. Right. So essentially 5 minus 2, 6 minus 4 in a printed form. Distance is equal to root 13. It's a very simple one. The last part is asking us to use the area of triangle formula. We need to find out area of the triangle formed by joining ABC. These are the coordinates. We know the area formula. Let's apply it. This is equal to half into x1, y1, x2, y2, x3, y3. So x1, which is equal to 2 into y2 minus y3, which is 6 minus 4, plus x2, which is a 5 into y3 minus y1, which is 4 minus 4. Good number to work with in terms of calculation. x3, which is an 8, y1 minus y2, which is 4 minus 6. So this is equal to half into 6 minus 4 is a 2. 2 times 2 is equal to 4. This is a 0. 4 minus 6 is a minus 2. 8 into minus 2 is equal to minus 16. So 4 minus 16 is a minus 12. Half into minus 12 is the answer, which is equal to minus 6. The numerical value is all that counts. Ideally, we would have wanted to write this formula as a modulus. So modulus of minus 6 or the numerical value, 6 square units, is the area of the triangle formed by joining these 3 points A, B and C. Summarize it in a printed form. Basically plugged in the values x1, y1, 2 and 4, x2, y2, 5 and 6, x3, y3, 8 and 4. To get the answer is minus 6. Numerical value of minus 6 is the area, which is 6 square units. So this topic, again, the area of triangle has been tested in almost every single paper that I've seen. Exactly 4 concepts: distance formula, section formula, midpoint formula, which is a special case of section formula with the ratio being 1:1, and area of triangles and the way they have been tested. Run through this. This is a topic which usually gives you anything between 3 to 4, 2 to 3 questions, and at least one 4-mark question typically appears from this topic. Right? Get a good handle on it. Best of luck with this topic and with all other topics for your board examinations. Before you leave, do 2 things. Sign up at online.maxtute.com for CBSE online coaching for class 10 maths. Takes less than 5 minutes in all of 3 steps to get started. And do one more thing. Subscribe to this channel, youtube.com/maxtute, and spread the word about this channel to your friends and classmates.